So, this is probably the third time that you've seen radians and degrees, right, talked about or explained. Sorry, I'm off the screen. There you go. You definitely saw it in Algebra 2. I'm pretty sure you should have seen it in Algebra 2. And then you probably saw it also talked about, introduced, right, in geometry. And so this is maybe a little bit of old hat for you, so I don't want to spend too much time on the origin of it. But on the other hand, I think it is a little bit of a confusing topic for students sometimes. So I do want to cover it again just because it's going to be necessary. We are moving into our trigonometry unit. Thank you. This class is called Pre-Calculus with Trigonometry, okay? And so, this is the trigonometry part, okay? We're going to spend more than just one unit here. We're going to, at least this is where we're starting now with the trigonometry stuff. Okay, so going back to our idea earlier, right, we saw that the circumference of a circle, right, going around the outside, another way, the perimeter, right, to say that, the perimeter of the circle is exactly 2 pi radiuses, or 2 pi radiuses to go around the outside, right, which is approximately, 6.28, right, approximately 6.28 radiuses to go around the outside of a circle. On top of that, though, right, we also have another way to kind of go around the outside of the circle, right? We can measure the outside of the circle, or going around the outside of the circle, in degrees too, right? And so the degrees, how many degrees does it take going around the outside of a circle? 360, right? So in a certain sense, then, we have this idea that 360 degrees, okay, which is also like going around the outside of the circle, is going to be the same idea as 2 pi radiuses, or again, like we said, we changed the word to radians. Okay, and that is where this kind of equivalence comes up. Okay, so degrees and radians, they are two different ways, two different units, I should say, two different units to measure the same thing. Okay, both involve measuring angles. It's just different units. So it's like someone might measure a length in inches, someone might measure a length in centimeters, right? And you can convert between the two by just multiplying by a certain scale factor and stuff like that. So yeah, you can cycle. Yeah. So 360 degrees is equal to 2 pi radians because both involve going one full kind of rotation around the circle. So with that being said, then we can say other things. For example, 180 degrees, right, will be equal to how many radians? What's that? 1 pi, or just pi radians, right? How did you get that? How did you know that was going to be this case? If we went from 360 to 180, what's the relationship there? Half, right? And so, likewise here, if these are equal, right, if we did half from here to here, then half from here to here should be the same thing. And it is true. 180 degrees is equal to pi radians, or 3.14 radiuses, or something like that. Okay? So we can keep going, right? We keep going half. So another half would be 9 degrees, which is then how many radians? So pi halves, or 1/2 pi. Typically we write it as pi over 2. Okay, we put it like in a improper fraction, I guess you'd say. But if you put 1/2 pi, you're not wrong. Okay, you're not wrong. All right, we could do it one more time here, right? And say like 45 degrees. Okay, and what would that be in radians? Pi over what? 4, that's right. Pi over 4, again, half again, right? We're just halving. But then we get to the question like, okay, that's great, Mr. Wade, but what about something like 20 degrees? Okay, how many radians does that equal? Because that's not, half of any of these. Well, I guess there is one we could do a fraction of here. Well, 2 we could do a fraction of here, right? So we could do fractions of 180 or fractions of 360. So we could say, 20 degrees is what fraction of 180? Anyone know that? What's that? 1/9, right. So then if it's 20 degrees and that's 1/9 of 180, then how many radians do we expect it to be? Pi over 9, right? Yeah, 1/9 of pi, so pi over 9. Okay. So maybe we can kind of figure it out still using fractions and stuff. All right. But of course, sometimes there's even more complex ones. For example, let's say we've got 21 degrees, and we want to know how many radians that is. Well, 21 degrees, that's not a nice fraction of any of those things. But the idea, the principle behind it is the same, or very similar at least. All right, and so that's what we're going to do here. We're going to convert from degrees to radians, but also back too, from radians to degrees as well. We want to be comfortable with that. Okay. And so there's many ways to do this. All right, some teachers like to just have you like multiply your degrees or radians by pi over 180 or 180 over pi, depending on which one you're converting to and stuff like that. I like to set up a proportion, okay? Because they're just so, I don't know. It seems to me like it's a little bit less guesswork, I want to say. So we'll take that 21, okay, and we'll put it in a ratio with its unknown quantity of radians, okay? So say 21 over x, right? We'll say that's the ratio of degree to radian, right? And we'll put that in the same ratio of another degree and radian relationship. But this time, we'll use numbers that we know, right? We have some relationships already. So for example, if you wanted to, you could write 360 over 2 pi here if you wanted to, right? You could write 180 over pi. You could put 90 over pi over 2. You could put 45 over pi over 4. You could put 20 over pi over 9 if you really wanted to here. I'm going to use the 180 over pi because it's nice and simplified, right? 360 over 2 pi, that simplifies. 90 over pi over 2 is kind of messy because it's got fractions and fractions and stuff, but this is pretty straightforward, right? And so we know that this relationship right here, 21 to its unknown equivalent radian measure, must be in the same ratio as 180 to its equivalent radian measure of pi. And so how do we solve a proportion? What do we do? Cross multiply. Okay, so 21 pi equals 180x. Okay, we leave the pi unmultiplied, right? Don't multiply it through by pi and get some funky decimal. We try and leave the pi out so we get some nicer numbers. And the final step here, we divide both sides by 180, and so we get 21 pi over 180. And then we try and simplify that fraction, right? Does 21 over 180 simplify at all? Yes, we can divide the top and bottom by what? By 3. So 7 pi over 60. Okay, 7 pi over 60. Or, if I did that as a decimal, let me just do that here real quick just so you can see it. It is 0.367, I'll say. Okay. In the context of, a circle then, if you did 21 degrees around the circle, right, so 21 degrees of the circle, that is about 0.367 radiuses, right? So you can measure a 21 degree arc on your circle, so I don't know, something like, okay, you can measure a 21 degree arc on your circle, or you could say this length right here, this length is 0.367 radiuses, or really radians. I'm not even going to write the word radiuses there. Okay, 0.367. And you might be like, Mr. Whitmire, that circle could be really big or that circle could be really small. Right, but remember that the radius, when the circle gets big, the radius also gets bigger. And when the circle gets smaller, the radius also gets smaller. And so the fact that we're calling them, the radians there, it's going to be this fraction of the radiuses that go around there. Okay, they grow in similarity. The size of the circle changes the same factor as the length of the radius does. Okay, the circumference changes the same factor. Okay, so that's the idea there. So why don't you guys go ahead, try this one. Convert 300 degrees to radians. Okay, so go ahead and give that one a try. Convert 300 degrees to radians there. because what we're trying to do here is convert from degrees to radians, right? And so we need to set it equal to a known ratio of radians and degrees, right? If we set a degree and a ratio to radius in this proportion, ratio, we need to come up with another degree and radian measure that we know. So you can use any of these in there. I chose the 180 over pi because that's like the most simplified one. But so the ratio of these two must be the same ratio as these two as well. So yeah. What's up?
There are triangles in the circle.
We'll get to that eventually.
Is that the unit circle is not hanging?
Say again?
The unit circle that's not
I don't. Yeah, I think you're right. There's some.
because the last one, Mr. Thompson gave us a choice of two.
Gotcha. Yes, we'll be doing those two.
Yeah.
So.
And you went for
Yeah. So anyway, here are. Oh, sorry, not here. So let's go to Rebecca. Rebecca, were you able to come up with an answer here? Actually, just like in terms of pi, I'll say.
I got 5 pi over 3.
5 pi over 3. Okay. Very good. Yes, 5 pi over 3. So again, our setup here, right? 300 degrees is how many radians? And we'll put that 180 over pi here. Again, cross multiply, right? So we get 300 pi equals 180x. Divide both sides by 180, you get 300 pi over 180, like that. And the 300 and the 180, they simplify, right? Well, they both can divide by 10, so we get 30 pi over 18. And they also both divide by 6, right? And so then we get 5 pi over 3, like that. Okay? And so there it is in pi, simplest terms with pi in there. We're doing multiply the pi through, okay, in terms of pi. Questions on any of that so far? We're good? All right, let me do one real quick here, also converting from, of course, radians then back to degrees, right? And so we'll just try that one here. So let's do 5 pi over 6. Radians to degrees. Or 5 pi over 6 radians to degrees. Now, typically when you see an angle measure, okay, talked about, if you don't see a degree sign, then you assume it's in radians, right? We typically don't write 5 pi over 6 radians. We don't give the units there. We just say 5 pi over 6, or 5 pi over 3, or pi over 2, whatever. We don't put the radians there, but it is what it is. They're radians, okay? Unless you see the degree symbol, in which case you're talking about degrees. All right, so the same principle applies here. 5 pi over 6, though, is now what we're going to convert. So I'll say 5 pi over 6. That'll compare to x degrees here, right? And so now that I have radian measure over a degree measure, when I go over here, what number should I put up top here? So it's a radian measure over a degree measure. So if I was using that 180 in the pi again, which one of those should go on top here? Well, it's a radian measure on top here, so what's another radian measure that we know? Well, it's the pi, right? Yeah, we know the pi. Okay. And so then what measure goes here on the bottom? The 180 degrees, right? Okay. Again, it was radians over degrees, radians over degrees. Mr. Whitmire, what if I did like x over 5 pi over 6? What if I wrote it like this? Kept my degrees on top like we did in the last problem, radians on the bottom. That's fine. Then it would just be equal to 180 over pi, like that. And you would still cross multiply and solve, be the same thing, okay? It's going to be the same thing, right? You just do the reciprocal of both sides, it'd be the same thing. So cross multiply here, you get pi x equals, now we got to do 180 times 5 pi over 6. Okay? Well, the 180 and the 6 can simplify, right, to be 30 and 1. And 30 times 5, is 150. So you get pi x equals 150 pi, and so x equals 150, and that's, of course, in degrees now at this point. Okay, so 5 pi over 6, 150 degrees. Okay, So you guys try one more here. How about 7 pi over 6? Making it worse. Okay. So again, convert 7 pi over 6 to degrees. 7 pi over 6 to degrees. Okay. Ratios set up. So when you cross multiples, yeah. So like when you multiply here, right? This is really like 180 over 1. So you can like simplify the 180 to 6, for example, and make it just 30. So that 180 becomes 30, and the 6 becomes 1. And then you can Okay. 210 is what we should have gotten there. 210. Okay. So, as part of this unit, right, it's going to be super important that we understand trigonometry and not only understand it, well, not only understand it, I guess, but understand it like pretty well to the point where we will be having some timed quizzes. If you had Mr. Thompson last year, they'll be kind of like that, but not quite the same thing, okay? We're going to have only 5 of them, all right? And they'll have different topics and stuff like that. I guess I should figure out, when would the first one be? It probably won't be for a couple days at least, but let me just check and make sure here. So I think the first timed one will be, let's see, let me switch these two here. So that's there, that goes there. Friday, I think. The first time trig quiz will be Friday, okay? And that'll be on regurgitating the unit circle, which I think we'll be talking about tomorrow as the unit circle. Or not tomorrow, Thursday, because, yeah. Okay, so anyway. One other thing I wanted to mention here. So I guess any questions on converting? Any questions on converting? All good there? Okay. So then one other thing I wanted to discuss was coterminal angles as well. Okay.
So what is this going to be, a full page or like?
No, it won't be. It'll be like this much.
Oh,
Okay. So coterminal angles. These are angles that share the same starting and ending positions. Okay? Angles that share the same starting and ending position. Right? Again, mathematicians, we're not super creative when it comes up to names. We kind of just like Name them like they are, right? So coterminal, co-share, terminal, right? We normally think of terminal as being a stopping place, but if you think about something like an airport, right? A terminal is the thing that you go to both start a journey and to stop a journey, right? Because when you get on the plane, you're at the terminal, and when you get off the plane, you're also at the terminal and stuff like that too, right? So coterminals share the same starting and stopping point, all right, for your angles. So for something like an angle like this, right, we might say that this angle, we might label that angle as like 30 degrees. Okay. And we wouldn't be wrong there. Okay. But if we start here again, right, on this ray, and we rotate that 30 degrees to create the angle, but then if we, well, let me do it this way. So if I start here at this starting side, okay, and we rotate one full rotation, how many degrees is that? How many angles? How many degrees is that? 360, right? And then to end in the same position, so again, we start in the same spot, we rotate 360, and if we then end in the same position end in the same position as the other angle, we're going to end up with that angle being, well, 390. Right? Isn't that angle also 390 degrees? It gets you in this, it has you start in the same place, has you end in the same place, and so that angle opens up, the same quantity there. So we could also say that angle is 390 degrees. It'd be the same position, I guess I'll say. Okay, obviously the values aren't the same, but it has the same starting point and the same stopping point. They are coterminal. All right. So what did we do there? We took our 30-degree angle that we started with, right, and then we did that 30-degree angle, and we added 360 degrees to it. And that gave us 390 degrees. And these are, again, coterminal. What direction did we rotate? What direction did we rotate here when we were measuring these angles, by the way? How would you describe it? Counterclockwise, right, or anti-clockwise, that kind of thing. Right, so counterclockwise, who says we have to go counterclockwise, right? Well, no one, really. We can go the other direction. We can go clockwise, right? So then clockwise, we could, again, start here and rotate around to this point right here. Okay? What would that angle measure be there? Negative 300 degrees. Why negative? Going in the opposite direction we normally would, right? So a clockwise direction is actually a negative motion when it comes to degrees and angles and stuff, right? Okay? And then, right, how'd you get 300 degrees, Parker? How'd you get that?
I got 3/3.
Oh, I'm sorry. How'd you get 330 degrees, Parker? Sorry.
I subtracted 360 degrees from 30 degrees.
Right, so one full rotation would get us right back to where we started, right? If we want a full rotation here, it'd be right back to where we started, 360 degrees. But we're not going a full rotation, we're going 30 degrees short of a full rotation. So 360, take away that 30, and you're left with then the negative 330 degrees here. So, okay, in the green. And so, you can take that 30 degrees and subtract 360, and that'll give us then that negative 330 degree coterminal angle there. Okay. So 390 and negative 330 are coterminal to 30. Or they're all coterminal to each other, really. Okay. So when it comes to angles then, if we're given a particular angle, for example 30 degrees, and if we want to come up with more angles that are coterminal to that 30 degrees, what can we do? Add what? Add multiples of 360, which would include also then subtracting 360 as well, right? Because you can talk about positive multiples or negative multiples of 360. Yeah. So for degrees, to find coterminal angles, plus or minus 360, plus or minus 360. I guess we'll put like a K here. Okay, so like multiples of 360. Okay, multiples of 360 degrees. Well, if for degrees we're adding multiples of 360 degrees, if I wanted to find coterminal angles for angles that were in radians, what would be the equivalent thing to do there? Adding 2 pi, right? Two multiples of 2 pi, or subtracting multiples of 2 pi, right? If for degrees, to find coterminal angles, we add or subtract 360s, for radians, we're just going to add or subtract 2 pi's, right? Because that's what's equivalent there. So for radians, plus or minus 2 pi radians to your angles. So for something like 7 pi over 6, if we want a coterminal angle, we'll add 2 pi to that. Okay. In order to add these two things together, what do we need, though? Can we add them together as they're currently written? So the answer is no, right? We can't add them together as they're currently written because we need what? Common denominators, right? So that'll be 6, right? So 7 pi over 6 will stay that. 2 pi is how many sixths? 12 pi sixths, right? Yeah, we're going to multiply the top and bottom by 6 there to get the... Okay, and so that gives us then 19 pi sixths. Okay, so this is coterminal to 7 pi over 6. Right? And of course, we can keep going. We could add another 12 pi over 6 and get, 31 pi over 6. We could do it again and get 43 pi over 6. Okay, we could subtract 12 pi over 6 and get like negative 5 pi over 6, right? Or negative 17 pi over 6, so on and so forth, right? Dot, dot, dot. You get the idea. Okay, there's an infinite number of solutions there. Okay, infinite number of solutions. All right. Excuse me. So I think that's all I have to say about that for today then. Okay? So any questions on any of that? Oh yes, Pramika. Not subtracting, adding 7 pi over 6. We're starting at 7 pi over 6, our original measure, right? And we're adding multiples of 2 pi or subtracting multiples of 2 pi. Or in our case, 12 pi over 6, right? Because you start at 7 pi over 6, you need a common denominator. So 12 pi over 6 is the common denominator there for 2 pi, and then you are in the terms of the sixths. So yeah, multiple 12 pi over 6s versus subtract 12 pi over 6s from 7 pi over 6. Other questions? Okay, so your homework is on Google Classroom. I recommend you go ahead and get started on that. If you finish that up, I also have 3 TenMarks assignments posted. One dealing with logarithms, one dealing with exponents, and then one dealing with radians. And the test, I'll get those back to you right now. Yes, test I'll get to you right now. Okay, and sorry, the TenMarks are due Monday. Yes, Riley. TenMarks are due Monday. Yeah.